Our goal is to make the best tasting coffee with the least amount of energy, and roasting is where that goal is won or lost. It's by far the most energy-intensive step in the whole process. A 120-gram batch can take upwards of 0.25 kilowatt-hours, and energy isn't the only thing we have to worry about. A failed roast, whether under-roasted, burnt, uneven, or baked, ruins the coffee no matter how well it's brewed afterward. That pressure shapes two of our biggest decisions, the blend and the roast level. Our blend is 70% Colombian and 30% Rwandan beans. The Colombian brings a dark chocolate flavor, but not much sweetness. The Rwandan brings the sweetness, but also green vegetal note we wanted to avoid. Blending the two lets us borrow the strengths of each. For the roast itself, we chose light medium. It's more energy efficient and matches what our judges preferred, a less bitter cup. Our roaster has two settings that do the work, fan speed and power. The fan moves the beans through the chamber for an even roast, but running it faster also cools the chamber and draws more power. The power setting drives the heater directly. The higher it's set, the more heat it produces. Electric heaters convert power to heat at nearly 100% efficiency, so in theory, the power setting shouldn't affect total energy use. In practice, it does. A lower power setting means a longer roast, and a longer roast means the fan runs longer too, burning more electricity overall. So we run the roaster at max power for the entire roast. We start at a fan speed of 9, because unroasted beans are heavy and full of water and need strong airflow to roast evenly. About 30 seconds in, once the beans have lost some of that water, we drop it to 8 and keep lowering it from there as the beans get lighter, always keeping just enough airflow to circulate them. Around the 4-minute mark, the beans start cracking. Once that cracking turns rapid, like popcorn, we begin the cooling cycle. Fan down to 4 for 1 minute, letting residual heat finish the roast without baking the beans and dulling their flavor. Then the fan goes up to 8 and the cooling cycle wraps up. Because we're cutting it this close for the sake of efficiency, a few beans inevitably end up underdeveloped, so we sort those out before brewing. What's left is a roast that just uses up 0.11 kilowatt-hours, less than half the energy of a traditional roast. Our grind size was 14. We decided on this size in an effort to have a large surface area to get most of the amount of the bean flavors in our brew, and to have less time for the actual extraction. When it comes time for the competition, we grind up the beans 30 minutes before brewing. This allows the beans to oxidize and off-gas, which they weren't given enough time to as we roasted them the day before. When those 30 minutes pass, we use our electric water heater to heat the water up to 94 degrees Celsius. We originally tried it on 85 degrees Celsius to save energy, but it didn't make that much of a difference in terms of energy, only about 0.01 kilowatt-hours. At first we want to use the AeroPress as our brewing method because it allows us to change the pressure while dispensing. However, we weren't able to use the AeroPress effectively and its capacity was small, so we chose the Clever Dripper as a brewing method. We chose a brew ratio of 17 in order to extract the flavors of dark chocolate with hints of a comforting smoky flavor. There are very little amounts of bitterness, if any. We then used a 3-minute extraction time to not get overwhelmed by this flavor or the bitterness if it comes through. The TDS is 1.36% and the PE is 18.207% in order to attain these flavors in even body. For the future, something we could improve on is how we could have tested with the AeroPress more, because we could have gotten similar results with colder water and therefore less energy. Additionally, if we had been allotted more time for brewing, we could have used cold brew, requiring 0 electrical energy.